Hello my dear students, in this lecture we are going to see one previous year GATE numerical on CI engine, that is compression ignition engine, means diesel cycle. This question was asked in GATE 2014 for 2 marks in set number 4. Now let us understand the question. Now while reading the question, after every statement I will write down the given data. Now here question is, in a compression ignition engine, that means they are mentioning compression ignition engine, and compression ignition engine is nothing but CI engine, which is called diesel cycle. It is a diesel cycle. Then the inlet air pressure is 1 bar and the pressure at the end of isentropic compression is 32.42 bar. Now inlet air pressure means P1, right? Inlet air pressure means P1 is 1 bar and pressure at the end of compression. Now 1 to 2 process is compression process, therefore P2 is given at the end of compression is 32.42 bar. These pressures are given. Now the expansion ratio RE, expansion ratio for the expansion process, expansion ratio RE is equal to 8. Now assuming ratio of specific heats gamma is equal to 1.4, here ratio of specific heat means Cp divided by Cv, which is nothing but gamma is nothing but 1.4. The air standard efficiency in percentage is, now here you have to write down the answer. Now what is the efficiency in percentage, right? We have to put the answer up to 2 decimal places. Now let us solve this question. Here I am deleting the question so that we will get sufficient space for the solution. Now here as diesel cycle is given, let us draw the diesel cycle, right? If I draw diesel cycle, in case of diesel cycle, the processes on PV diagram are like this: pressure versus volume diagram. Now very first process is reversible adiabatic compression, therefore 1 to 2 is reversible adiabatic compression. 2 to 3 is constant pressure heat supply. 2 to 3 is constant pressure heat supply. At constant pressure heat will be supplied. Now 3 to 4 is reversible adiabatic expansion. 3 to 4 will be reversible adiabatic expansion. And 4 to 1 is constant volume heat rejection. Constant volume heat rejection. Heat rejected at constant volume, heat supplied at constant pressure. And compression is reversible adiabatic, expansion is reversible adiabatic. This is the diesel cycle. And my dear students, the ratio of V1 to the V2 is called compression ratio. Therefore here it is represented by RK, which is nothing but V1 divided by V2. Similarly, the ratio of V3 to the V2, V3 divided by V2 is called cutoff ratio, RC. V3 divided by V2 is cutoff ratio. And ratio of V4 to the V3 is expansion ratio, RE, which is nothing but V4 divided by V3. And this expansion ratio is given in the numerical. And efficiency of diesel cycle in terms of compression ratio and cutoff ratio, we have derived the formula in theory lectures. This efficiency of diesel cycle is equal to 1 minus 1 upon RK raised to gamma minus 1 into, in bracket, RC raised to gamma minus 1 divided by gamma into RC minus 1. This is the formula that we have derived in theory lectures. So my dear students, for finding efficiency of diesel cycle, we need to calculate RK, compression ratio. Gamma is, I think, given. Gamma is already given. And we need to calculate RC, that is cutoff ratio. Then only we can find the diesel cycle efficiency. So my dear students, here this RE is given. Now can you say here, this RC into RE is equal to, RC is V3 divided by V2 and RE is V4 divided by V3. Therefore V3 will get cancelled and it will become V4 divided by V2. And my dear students, here V4 to V1, it is constant volume process, therefore V1 is equal to V4. Therefore this RC into RE is nothing but V4 divided by V2. We can write like V1 divided by V2, and this V1 divided by V2 is nothing but a compression ratio, which is equal to RK. Therefore from this we get one idea that compression ratio is equal to expansion ratio into cutoff ratio, right? This is very important parameter. Now let us put this side and later we will use this result and this formula for the efficiency, right? We have one formula that compression ratio is equal to expansion ratio into cutoff ratio, right? Now the process 1 to 2 is reversible adiabatic compression. Therefore the equation for reversible adiabatic compression is T2 divided by T1 is equal to P2 divided by P1 raised to gamma minus 1 upon gamma is equal to V1 divided by V2 raised to gamma minus 1, right? So equate second and third. From this equation you will get P2 divided by P1 raised to gamma minus 1 upon gamma is equal to V1 divided by V2 raised to gamma minus 1, and V1 divided by V2 is compression ratio, therefore is equal to compression ratio raised to gamma minus 1. Now from both side gamma minus 1 power will get cancelled, right? From both sides this power will get cancelled, therefore the equation will become P2 divided by P1 raised to 1 upon gamma is equal to RK, compression ratio. So my dear students, let us find this compression ratio. If we find this compression ratio, now no need of diagram now, right? Put the values here on upper side left box. I am finding this compression ratio, right? Therefore RK is equal to P2 divided by P1 raised to 1 upon gamma, which is nothing but P2 is nothing but 32.42 given in the question, divided by P1 is 1 raised to 1 upon 1.4. So from this you will find compression ratio, that is RK, which is nothing but V1 divided by V2, and you will get answer as 12. Therefore compression ratio is equal to 12 and gamma is 1.4. Now we need RC value to find efficiency, right, to put in this formula. Now we have this compression ratio is equal to expansion ratio into cutoff ratio. Therefore from this we can say cutoff ratio is equal to compression ratio divided by expansion ratio, which is nothing but 12 divided by 8. Cutoff expansion ratio is given 8, which is nothing but 1.5. Therefore RC is equal to 1.5. Now we have all the values, so let us find the efficiency. Now I am erasing everything here. We are going to find directly efficiency, right? So my dear students, for finding efficiency we need RK, which is nothing but 12, we need RC, which is nothing but 1.5, and we need gamma, which is nothing but 1.4. Gamma is 1.4, and efficiency formula, efficiency of diesel cycle is equal to 1 minus 1 upon RK raised to gamma minus 1 into RC raised to gamma minus 1 divided by gamma RC minus 1. So in this formula put all the values. Therefore efficiency of this diesel cycle is equal to 1 minus 1 upon RK is 12 power 1.4 minus 1 into RC is 1.5 power 1.4 minus 1 divided by gamma is 1.4 into RC is 1.5 minus 1. Now with the help of this formula let us put all the values and in calculator and find out the efficiency. If you solve this for the efficiency, you will find that the result will be 0.596. That means, but in question they are asking you what is the efficiency in percentage. You cannot type this in the examination. If you type this answer, you will get 0 marks. This is the fill in the blank question. Yes, you will get 0 mark. For fill in the blank question, there is no negative marking, right? They are asking in percentage. Therefore efficiency of diesel cycle in percentage is equal to 59.6%, right? And this answer you have to type in the fill in the blanks. Means you have to type 59.6. For typing this you will get full 2 marks, and any other result if you type 0.596 you will get 0 marks, my dear students. Thank you dear students. In next lecture we will see one more numerical on diesel cycle.